In question number 11, in a transistor in CE configuration mode, that is common emitter configuration mode, R0, that is the resistance across load, is equal to 4 ohm, Ri, input resistance, is equal to 1 ohm, IC, current in the collector, is 1 milliampere, and IB, base current, is 50 microampere. Then the voltage gain is, so we know that in case of CE configuration mode transistor, voltage gain V output upon V input is given by beta into R0 upon Ri, where value of beta is equal to IC upon IB. So if I substitute the value of IC and IB, then the value of beta comes out to be 20. So if I calculate the voltage gain, that comes out to be 20 into R0, that is 4 kilo ohm divided by 1 kilo ohm. So it comes out to be 80. So option 2 is the correct answer. So the correct answer for question number 11 is option 2. Let's move to question number 12. In question number 12, the mass density of a spherical body is given by rho r is equal to k by r for r is less than equal to capital R, and rho r is equal to 0 for r is greater than capital R, where r is the distance from center and k is a positive constant. Gravitational field E will vary with distance r from the center S. Suppose this is a spherical body of radius capital R and the mass density is varying as rho is equal to k by r. So we have to find out the variation of the gravitational field with respect to r. So if I consider a spherical shell at a radius r of thickness dr, suppose the thickness of this spherical shell is dr, then the mass enclosed between two spherical shells is less dm, which can be written as rho into 4 pi r square dr. So if I calculate the mass from 0 to r, this mass m is integration of dm, where r varies from 0 to r. So it comes out to be, if I substitute the value of rho, that is k by r, so it comes out to be 4 pi k into r dr integration from 0 to r. So it is equal to 4 pi k into r square by 2. Then the gravitational field at this point is equal to G into m by r square, because the gravitational field due to outer shells is 0 at the inside point. So if I substitute the value of m, so it comes out to be 4 pi kg by 2 or 2 pi kg, which is constant. So from here to here, that is up to capital R, the gravitational field value is constant. And if I goes outside of the spherical body, suppose at this distance, if I write the gravitational field, then I have to check what is the value of this mass. So this mass comes out to be integration of dm. Now the limit changes from 0 to capital R. So if I calculate this, it comes out to be 4 pi k into r square by 2. So if I write the gravitational field at the outside point, then the gravitational field at the outside point is equal to G into capital M. So that is 4 pi k into r square by 2 divided by small r square. So this is inversely proportional to r square. So from 0 to capital R, it is constant, and afterwards it is inversely proportional to r square. So option 1 is the correct answer. So the correct answer for question number 12 is option 1. Let's move to question number 13. In question number 13, an ideal monatomic gas is made to undergo a thermodynamic process given by P is proportional to T square. Molar heat capacity of the gas for the given process is. So it is given in the question the gas is ideal. So if I replace the temperature, then we know that PV is equal to nRT. So T is proportional to PV. So I can say that P is proportional to P square V square, or P into V square is equal to constant. So if I compare with the polytropic process, PV की power x is equal to constant, then on comparison, the value of x comes out to be 2. And in the polytropic process, the molar heat capacity is given by C is equal to Cv plus R divided by 1 minus x. Since the gas is monoatomic, the value of Cv is 3R by 2, plus r divided by 1 minus 2. So on solving it comes out to be r by 2. So option 4 is the correct answer. So the correct answer for question number 13 is option 4. Let's move to question number 14. In question number 14, a block kept on a horizontal plank is performing SHM along a vertical line with amplitude 1 by 25 meter. The block loses contact with the plank at an instant when its velocity becomes 0. The time period of oscillation, and it is given the value of pi square is 10. Suppose this is the horizontal plank and a block is kept on it, and this plank is performing oscillation in the vertical direction. Suppose this is the mean position. So when the plank is at the bottommost position, then there is no possibility that the block loses the contact with the plank. But when the plank is at the topmost position, then there is a possibility that at the instant when the block have a velocity 0, it loses a contact with the plank. So at this instant, the value of x is equal to a. So if I write the acceleration of the block at this moment, so the acceleration is omega square into a, which is restoring in nature. So the value of a at that moment is g, as the block loses the contact with the plank. So from here, the value of omega square is equal to 4 pi square by t square, which is equal to g by a. So if I substitute the data, 4 pi square by t square is equal to g, that is 10, divided by a, amplitude is 1 by 25, so it is equal to 1 into 25. It is given in the question that the value of pi square is 10, so this value gets cancelled out. So from here, the value of t comes out to be 4 by 25 under root. So it comes out to be 2 by 5, and it is further, it can be written as 0.4 second. So option 3 is the correct answer. So the correct answer for question number 14 is option 3. Let's move to question number 15. The surrounding temperature above the lake is minus 5 degrees centigrade and remains constant. It is found that a 4 centimeter layer of ice is formed in 10 days on the surface of the lake. In how many days further will the thickness of the ice increases to 6 centimeter? So from the theory of accretion of ice, we know that the time taken t is equal to L into rho upon 2 times K into theta, that is the temperature of the surrounding, into x square, where x is the thickness of the ice layer formed on the surface of lake. And the remaining variables are standard. So in this formula we can say that since these variables are constant, so t is proportional to x square. So in the first case, it is found that a 4 centimeter layer of ice is formed in 10 days. When the thickness of the ice is 6 centimeter, the total time taken is t. So I can say that t by 10 is equal to 6 square divided by 4 square. So on solving, the value of t comes out to be 22.5 days. Now in the question it is asked, in how many days further will the thickness of the ice increases to 6 centimeter? It means that the remaining 2 centimeter thickness of ice is formed in 12.5 days. So option 4 is the correct answer. So the correct answer for question number 15 is option 4. Let's move to question number 16.